Good day, students! Welcome to our teleradio-based instruction for Math 7 on air. How are you today? I hope that you are all ready for another episode for our math learning. I am Teacher Sweet of F. Bangoy National High School, your teacher broadcaster for today. I know you are excited for our lesson, so make sure you are prepared with the following: notebook, ball pen, ruler, and a coin or any circular object that you may use to draw a circle. During my discussion, I want you to take note of important things and participate in the activity that will be given later. In our episode today, you will learn what is a Venn diagram and how to use it in solving problems involving sets. This is based on the most essential learning competencies of the Department of Education for Math 7 Week 2, which is to solve problems involving sets using the Venn diagram. So, are you ready? Let's begin. To start with, let us have a review about a topic that you learned in the previous episode, that is on set operations. Can you recall what are these set operations? Very good! These are the union, intersection, difference, and complement of a set. These operations can be visualized by using a mathematical illustration which we call Venn diagram. This consists of geometrical figures which show the relationship, similarities, and differences among things or group of things. The two or more circles represent different sets, and a rectangle represents the universal set as shown in this illustration. So, how do we illustrate these different set operations using the Venn diagram? Okay, let's take a look at the first operation, the union of sets. Let us recall that the union of two sets A and B is the set of all elements that are in A, or in B, or in both A and B. Therefore, in this union of sets, the two circles representing the two sets A and B are both shaded. These shaded regions represent the solution to the set operation used. Alright, next operation is the intersection of sets. Remember that the intersection of sets is the set of all elements that are found in both sets. So, in using the Venn diagram in this example, A intersection B is the shaded part where the circles intersect or overlap. These represents the elements that are common to both sides. Okay, how about the third set operation, which is the difference of sets? What does this operation mean again? How do we illustrate this using the Venn diagram? Given the sets A and B, the difference of sets A and B, written as A minus B, is the set of elements that are in set A but not in B. Therefore, in the Venn diagram, the shaded region is the part of set A that does not overlap with the set B. On the other hand, the difference of sets B and A, written as B minus A, is the set of elements that are in set B but not in set A. Therefore, the shaded region is the part of set B that does not overlap with set A. Lastly, we have the complement of a set. In symbol, this is read as the complement of set A or A prime. This is the set of all the elements in the universal set U that are not elements of set A. In the Venn diagram, all the parts are shaded except set A. The same goes with the other illustration, read as the complement of set B or B prime. In this set operation, all the parts are shaded except set B. This means the complement of set B is the set of all elements in the universal set U that are not elements in set Now, we are done with the set operations and their Venn diagrams. This time, we will be solving problems involving sets. But before we do that, let us be familiarized with some words or phrases that are used to represent set operations in word problems. In union of sets, the word or is used. For intersection of sets, we have the words and, both, and the phrase all three. For difference of sets, we have the words only and the phrase but not. And for the complement of a set, we have neither nor for two sets, neither and but not for three sets. All right, this time, let us try to solve problems involving sets using Venn diagrams. Let us take a look at the given example. The problem goes like this. A survey with 60 respondents was conducted at F. Bangboy National High School for grade 7 section Magnolia. They were asked about what modality of learning they prefer. It was found that 10 students chose online learning, 46 students chose modular learning, and 6 students chose both of these two modalities of learning. These are the questions to be answered. Number 1, how many students chose online learning only? Number 2, how many students chose modular learning only? Number 3, how many students chose online modular learning? And number 4, how many students chose neither of the two? In solving a worded problem, it is very important that we analyze the problem carefully before answering. To do that, let's start by identifying the given data or information in the problem. One given data is 60, which is the cardinality of the respondents. Remember what cardinality means? It is the number of elements or members of a given set and uses the small letter n. So, in the given problem, 60 is the total number of students being surveyed. The cardinality of the universal set. Use the capital letter U for the universal set. What are the other given data? That's right, we have 10. This is the cardinality of the students who chose online as modality of learning. Use capital letter O for the set of students who chose online. In set notation, this is cardinality of set O is 10. Another given data? Correct! That is 46. This is the cardinality of students who chose modular learning. Use capital letter M for the set of students who chose modular learning. In set notation, this is cardinality of set M is 46. So, are there more given data? Yes, that is 6. This is the cardinality of students who chose combination of online and modular learning. In set notation, that is the cardinality of the intersection of set O and set M 6. All right! After analyzing the problem by listing the given information, we are now ready to answer the given question. To do this, let us use the Venn diagram and apply the concepts of set operations that we have learned. From the given problem, we can say that there are two sets being considered, one representing online learning and the other one representing modular learning. Question: can we say that the two sets overlap? Very good! Yes, they overlap, since there are students who chose combination of the online and modular learning. Now, let's draw the Venn diagram. I want you to participate with me in this activity, okay? First, draw a rectangle in your notebook. Then, using a coin or any circular object, draw 2 overlapping circles inside your rectangle. Name the first circle set O for online learning and the second circle set M for modular learning. On the upper left corner of your rectangle, write capital letter U, which stands for the universal set. Are you following? Okay, I hope you have drawn the Venn diagram correctly, just like what we have here. Did you get it right? Very good! Since you have already drawn your Venn diagram, let's fill it in with the correct given data. We will now apply what we have learned about the concepts of Venn diagram and set operation. Okay, let's start with the intersection where the 2 sets of circles overlap. In the given problem, 6 students chose both online and modular learning. Let us recall that the word both implies intersection. Therefore, we will fill in 6, the intersection of set O and M. We can write this in set notation as cardinality of O intersection M is 6. So, here it is. Now, let's go back to the questions one by one. In question number 1, it asked about the cardinality of students who chose online learning only. Maybe some of you will answer 10, but that is not correct. Remember, 10 is the total number of students who chose online learning, regardless if that student also chose modular learning. Instead, this is the part of set O which does not overlap with the set M shown in the shaded part of this illustration. So, what data are we going to fill in that part, which represents the cardinality of students who chose online learning only? Take note of the word only. What set operations uses the word only? Correct! It's the difference of sets. So, in set notation, we write it as cardinality of the difference of set O and the intersection of set O and set M. Since it is given that set O is 10 and the intersection of the sets is 6, our solution is 10 minus 6 equals 4. Therefore, there are 4 students who chose online learning only as shown in this illustration. Now, let's fill in 4 in the part of set O, which represents students who chose online learning only. Alright, have you followed the step-by-step solution we just have made? Good job, students! But we're not yet done. This time, let's answer question number 2. This question is actually similar to the first question. It asks us about the number of students who chose modular learning only, as shown in the shaded part of the illustration. This is the part of set M which does not overlap with set O. To solve this part, let's follow the same process in number 1. So, in set notation, it is the cardinality of the difference of set M and the intersection of set O and set M. Since it is given that set M is 46 and the intersection of set O and set M is 6, then the solution is 46 minus 6 equals 40. Therefore, there are 40 students who chose modular learning only. So, let's fill in the Venn diagram with 40 to the part of set M, which shows students who chose modular learning only as shown also in this illustration. Now, let's proceed with the third question. It asks about the cardinality of students who chose online or modular learning. Take note of the word or. What set operation uses the word or? Correct! It's the union of set. This is shown in the shaded part of this illustration. As you can see, the circles of set O and set M are both shaded. So, this question asks for the combined cardinality of the students who chose online learning only, the cardinality of students who chose both online and modular learning, and the cardinality of students who chose modular only. I know that in your minds, you already have an answer. What did you do? You may use another solution, but it's just fine. What is important, you have analyzed the questions correctly. In set notation, it is the cardinality of the union of set O and set M. In other words, that is 4 plus 6 plus 40 equals 50. Therefore, 50 is the cardinality of the students who chose online learning or modular learning. Now, let's proceed with the fourth question. It asks about the cardinality of the students who chose neither of the two modalities of learning. Here, the question made use of the word neither. So, what set operation uses the word neither? Very good! It's the complement of a set, as shown in the shaded part of the illustration. To solve for this, let's recall that the cardinality of the union of set O and set M is 50. Then, we will subtract this from the cardinality of the universal set, which is 60. Therefore, 60 minus 50 equals 10. So, let's write 10 outside of the circles, since this is the cardinality of students who chose neither of the two modalities of learning. All right! In conclusion, let us go back to the given questions. First, how many students chose online learning only? Yes, there are 4 students. Second question, how many students chose modular learning only? Correct! There are 40 students. Third question, how many students chose online or modular learning? That's right! 50 students. And lastly, how many students chose neither of the two modalities of learning? Very good! There are 10 students who chose neither online nor modular learning. In summary, these are the steps that we should remember in solving worded problems involving sets using the Venn diagram. First, read and understand the problem. Second, analyze the questions. Third, draw a Venn diagram. Fourth, identify the intersection of the sets. And fifth, perform the set operation applicable to the question. And sixth, write your conclusion. All right! That's it for our lesson today. I hope that you learned something from today's Math 7 on air. Don't forget to answer the activities on your module, because the only way to get better in math is to practice, practice, practice. For any question or clarifications, your Math 7 teachers are willing to assist you. Once again, this is Teacher Sweet. Until next time. Bye!